Hi, this is BitDive, a tool that helps developers analyze the performance of Java applications at the code level. With BitDive, you can identify bottlenecks, track calls between microservices, and automatically collect errors without modifying your code. Today, we will explore BitDive using a microservices based application as an example. We will try to identify performance issues, locate optimization points, and detect potential errors. If errors are found, we will analyze their origin and understand what caused them. We will work with a Spring Boot based microservices application. It includes an API gateway, Eureka, config server, and services for data management, report generation, and OpenAI integration. You can find this application through the link in the video description. Let's start with the heat map, which shows the hierarchy of our application consisting of multiple microservices. Here, we can monitor key metrics and detect system errors. Any significant changes in metrics will be reflected on the heat map by a color change. The greater the deviation, the redder the metric becomes. I've already noticed an error in the faculty microservice. Let's take a closer look at this error and analyze its insert course method. Diving into the method, I can see all the requests and spans that pass through this call. Oh, I can immediately spot the error message occurring within the service. And by the way, you get this without needing to modify your code in any way. Now let's take a closer look. On the call tree, we can see the entire chain of calls within this method, including database interactions and the points where errors occur. In this case, we see an error in the database interaction. We can also view the method arguments that were passed in, as well as the error details. I've noted that we'll need to investigate this issue further later. Let's see what else we can uncover in this application. I notice that the report microservice has the longest execution time. Clicking on the class, we can view key performance charts of the application with Performance Explorer. I can see from the chart that there were also some errors. Let's dig deeper and analyze the traces at the method level. Here, we can immediately see the errors that occurred during the application's execution. I also notice there's a call with an extremely high execution time. Let's take a closer look at it. Interestingly, this call was completed and returned a 200 response, yet it also contains an error. What could this mean? Yes, it seems there are issues during the method execution, and the Generate Report PDF method encountered an error. At the same time, we can see that the rest of the method executed without any issues. Let's see what interesting insights we can find during the execution of operations. One of the methods has quite a long execution time. I can see that it involves an internal REST request. Let's take a closer look. Viewing the request details, we can see all the information, including request and response headers, as well as the body. I also see a call to an external service marked with a globe icon. It seems this microservice is quite active in making external web requests as well as internal REST calls. But let's see what else we can find. Judging by the heat map turning green, the application's load seems fairly balanced at the moment. There are a few metrics in the red zone, indicating high execution times, but we've already reviewed that microservice. I noticed that one of the methods, getStudents, has an excessively high number of SQL queries, 2,726 to be exact. Let's investigate what's happening there and explore possible optimization options for the SQL query. While we're opening the call tree, let's think about how such a high number of SQL queries could impact the overall application performance, especially under heavy load. Reducing these calls might significantly optimize the system. Perhaps we should view this in timeline mode to spot any repetitive operations. We can also view the list of database queries in tree mode. Yes, it seems that one call contains 105 SQL subqueries. Here we can see all the requests made, including the SQL queries themselves. In tree mode, we can also reorder the nodes by process duration, allowing us to identify the queries that took the longest to execute. Let's take a look at the JVM metrics of our microservices. This dashboard provides real-time monitoring of Java Virtual Machine performance metrics across all your services. Here, we can see critical system metrics like CPU usage, memory utilization, thread management, and disk space. For instance, we can monitor how much heap memory is being used or track the number of active threads in real time. Let's move on to the Performance Explorer. This tool provides detailed performance metrics and visualizations for your microservices architecture, allowing you to analyze data from the module level down to individual methods. As you can see, the Performance Explorer gives us metrics for each method, including incoming HTTP requests, SQL query counts, average response times, and error rates. It also offers a hierarchical navigation structure, making it easy to drill down from high-level modules to specific controllers and methods. For instance, here we can track response time trends, identify spikes, and monitor SQL query execution patterns, all in real time. Let's analyze some of these metrics to identify potential issues and optimization opportunities. Here, we see the familiar insert course method and a chart showing the errors occurring within it. Drilling down further will take us to a detailed list of calls where we can analyze these errors more thoroughly. Now, as we look at the call tree with the errors highlighted, it becomes clear how powerful BitDive is in identifying performance bottlenecks and issues at the method level. This detailed visibility enables us to pinpoint problems and understand their root causes with precision. All of this is achieved by simply adding one library with no need for any code modifications. BitDive makes performance monitoring seamless and effortless. Thank you for joining this exploration of BitDive's capabilities. With tools like Performance Explorer, heat maps, and method-level tracing, you can optimize your applications, improve performance, and resolve issues faster than ever. See you next time.